Good afternoon. I'm Dylan Beattie, and the organizers of a .NET Summit have invited me to come back out to Minsk to talk to you about architecture, the stuff that is hard to change. Now, this is me. I'm Dylan Beattie on Twitter, which is the best place to find me if you want to talk about this stuff. I'm the CTO at Skills Matter in London, where I help organize all kinds of tech events, conferences, training courses. I write Ruby code, .NET, JavaScript, all kinds of stuff. I'm an MVP. Thank you, Microsoft, for Visual Studio and developer tools. I run a .NET user group in London. I also, has anyone heard of the Rockstar programming language? So I invented Rockstar so everyone can be Rockstar developers, because then we can all get those jobs on LinkedIn. So that's kind of fun. Check that out. Now, when I travel and speak internationally, I always try and make a bit of effort with language, you know. And so I went on to Duolingo, and I looked through all of the languages that they have there, and they do not have Belarusian, which is shocking. They have High Valerian and Klingon, but no Belarusian. So I thought, I know quite a lot of people here speak Russian, so I thought maybe I could learn a little bit of Russian to kind of help out with some of my content. So I did my Duolingo Russian language lessons, and it's taught me some useful things. Koshka nie lubi moja penie. All right. Projekt называется «Потому что архитектор все проспал». And this one, which comes up a lot when I talk about some of the code bases that we work with. Этот код настолько стар, что уже начал пить водку. But that's kind of where my Russian runs out, so I'm going to stick to English for the rest of the talk. And yeah, the title of this talk is architecture, the stuff that's hard to change. Now, how many people here, just raise your hands if you're a software architect. Raise your hands if you've got like an architect on your team, or you've worked with architects on stuff that you do. Because we have this word, architect, that we use in software. And we use it in construction. We have software architects, we have building architects. We don't have racing car architects. We don't have aeroplane architects, you know. And it's this weird, very specific word we have in software that people talk about. And we all know architecture is important, and we've all kind of, you know, had problems. We're like, actually, the code is okay, but maybe there's a problem with the architecture and the design and stuff. And what I'm going to do in this talk, I want to dig a little bit into not talking about software architectures. I'm not going to be showing you very much code and stuff. I'm going to talk about how to do that architect job, how to work with an architect, how to be a good architect if that's what you're working with. Now, the term software architecture comes from the 1990s. Before that, no one said software architecture. It was this book, which is Mary Shaw and David Garland. And it's a really good book. And one of the things they tried to do with this book was they took what they called a substantial folklore. Everybody, all these big teams, they all had their own stories and their own ideas about how to design and build big software systems. But there was no discipline. Nobody had written the stuff down. Nobody had given it a name. So that's where the idea of software architecture came from. But we've been talking about architecture in information for a lot longer than that, because way back in the 1960s, people were talking about computer architecture. And this definition I really like. This is a guy called Fred Brooks, who was a really influential scientist. He's still alive, actually, but he wrote the book The Mythical Man Month, which I'm sure some of you have come across. And in the 1960s, he was working at IBM on a thing called Project Stretch, and he wrote a great book about all the stuff they did. And he had this definition: computer architecture, like other architecture, is the art of determining the needs of the user of a structure and then designing to meet those needs as effectively as possible within economic and technological constraints. I want to dig into this definition a bit, because this actually gets us quite a long way. So architecture, three things: determining the needs of the user, designing to meet those needs within economic and technological constraints. Now, we're developers, right? We write the code and the users use the code. And the users get it wrong and they click the wrong button and users are stupid and our code is perfect, and this is how we build software, right? So if you're the architect, who are the users? Because one of the things that'll happen is you need to take a step back from that. Because the people who are filling out the forms and clicking the buttons and playing the games, they are not your users anymore. Your users are going to be the people who are writing the code. Your users are now developers. And this is where it gets difficult, because architecture is about designing software over a scale of years. And, you know, Agile and Lean are very, very popular in software development. So when you're working as an architect, you're not just trying to work out how to meet these people's needs, keep your developers happy. You've also got to think about the developers you haven't hired yet, who are going to turn up next year, who are going to be using systems you haven't thought of yet, to build products you haven't invented yet, to sell to customers that you haven't got yet. And you're going to keep these people happy, right? Now, it kind of sounds like if you're doing all this, you're probably going to need to make a plan, like this. And planning has got a bad reputation in software over the last few years. Who's familiar with the Agile Manifesto? Yeah. Agile has taken off in a big way. And I think Agile has actually done a lot of incredibly good things. Now, there's not many people know this, but this guy, this is René Descartes. He's a French philosopher. But before he was a philosopher, he was an Agile software consultant. And he was working with a client one day, and he says to them, you know, the Agile Manifesto says that we should respond to change instead of following a plan. And the customer says, oh, that's brilliant. We haven't got a plan. And Descartes says, sacre bleu, if you don't have a plan, how can you choose not to follow it? What Agile says, you know, the tenet of the Agile Manifesto, if you look at it, we have uncovered better ways of developing software by responding to change over following a plan. While there is value in the items on the right, we value the items on the left more. What they had seen happen over and over again was some company who were like, well, the software doesn't work, but the plan's right, so we're going to keep shipping broken software because that's what the plan says. We're way over budget, but the plan says we do this next, so we do this next. And those projects had failed. And the signatories of the Agile Manifesto said, well, have a plan. You know, we're not saying throw the plan away. We're saying if the real world changes and you realize the plan isn't helping, don't feel like you have to stick to it. There is another thing in the Agile Manifesto, one of the principles behind it that I want to talk about. The best architectures, requirements, and designs emerge from self-organizing teams. Now, I've worked on teams, and I admit I've probably run a few teams in my past, where we just kind of got a bunch of people together and we didn't help them. We didn't tell them what to do. We're like, oh, it's Agile, you can self-organize. And then you go back and you're like, is the project finished? They're like, no, we self-organized to another company and went and worked somewhere else. We self-organized to the pub and had beer and didn't come back. You know, self-organizing, it's kind of like the plan thing. It's one of these things, if you have a team who are doing great work, let them do great work. Get out of the way and allow them to work the way that they want to do. If you have a bunch of people come to you as an architect or a tech lead or a manager and say, boss, we're stuck, we don't know how to organize this, you need a better answer than just go and self-organize, because they're not going to do anything. You know, you have to be prepared to help people work this stuff out. And when it clicks, they'll organize themselves, and you can take a step back and just kind of watch it happen and watch the growth happen. So we talked about, you know, this idea of the needs of the user. When you're an architect, your users are developers and development teams. You're going to need a plan. You're going to need to engage with them to help them organize and coordinate what they're doing. What about constraints? We're going to go and get a job here. And this place has rules in the software department. No new hiring, no JavaScript, no open source, no Microsoft, no cookies. This is actually how Oracle writes software, by the way. You know, now, this is silly, but there are always going to be things you can do and things you can't do. And there are going to be things that are difficult, and there are going to be things that are expensive. And part of the role of architecture is understanding that, you know. Now, a lot of the time, boss will come to you and go, hey, can we just use AI to recognize our users through their webcams? And 20 years ago, you're like, what's a webcam? 10 years ago, you're like, don't be silly, AI isn't that good. Today, you're probably like, that's horribly unethical, and I don't really want to get involved in that. Maybe in 5 years' time, you're going to be like, I don't care, yeah, plug in, do it. Constraints evolve over time. The capabilities of technology change over time. When Apple brought out the iPhone 1 in 2007, everybody said you couldn't make a touchscreen phone. They said it won't work. The screens aren't good enough. Everyone had used, the kiosk at the airport where you push here and it clicks over there and it doesn't work and it's all horrible and scratched. And, everyone said no one ever wants a touchscreen phone. So no one was trying to build one. And it was an engineering team at Apple who went, actually, we think it's ready now. And, that sometimes is part of the role of architecture. Keep an eye on the horizon. What is happening in the industry that wasn't possible before? And can you use it? Can your team use that to deliver and do something amazing? A lot of the time, though, what your role as the architect is going to be is your team come back from a conference like this, and they go, boss, we got this amazing, shiny JavaScript we want to use. And you say, nyet, we have to support Internet Explorer. And they say, why? And you say, because one of our biggest clients is an investment bank who still use Internet Explorer. That's a constraint. We're building a system here that we sell to customers to give us money. You have to respect those constraints. And this is, sometimes developers get upset. And I'm going to tell you at the end what you can do about that. But, what we've done here, so let's look at that. We've got this idea of architecture as these three things. What are your users' needs? Your users are developers. They want to be able to deliver good software quickly now and in future. You want to meet those needs. You want to support them with plans, with ways of collaborating, with access and support for picking up new technology, and you need to respect the constraints. There's a limit on how many people you can hire. You have a budget. There's things technology can and cannot do. That there's legal and ethical restrictions around the ways you can use code to do things. So that's the definition of architecture that I'm interested in. Now, how do you do it? Well, this bit's really easy. 3 steps. Secret of software architecture. First, you make decisions, you communicate your decisions, and then you reinforce your decisions. Thank you very much. I'll see you next year. How do you make a decision? Someone comes to you, we want to do a thing. We want to build a distributed database, or you don't want a distributed database. What do you actually want? Dig a little deeper. Sooner or later, you're going to have to make some decisions which go into that plan, which is the thing that you use to support your teams and your engineers. Now, there are 5 things I think architects need to understand to be able to do this part of the job well. First of all, you have to understand what have you got. Now, in every organization, there is some code somewhere that does something. And frequently, certainly in my experience, what you've got there is a whole bunch of different systems that all do different things, and everyone thinks they know what the systems do. They think they know how the online checkout works. They think they know how the database tables work. Sometimes they're right, sometimes they're wrong. What you actually want to understand is the traffic that is flowing between those different systems. Now, a lot of people think about this idea of monitoring traffic. Think about it like border control. What's coming in? What's coming out? What does that traffic look like? How much is there? Are there peaks? Are there troughs? How much can we handle? How much do you put across this boundary before we start having a bit of a problem? Now, it's easy to think, oh, you're talking about, microservices and distributed architecture and stuff. No. I'm talking about anything that does software processing. Let's take the simplest architecture I could come up with for this. It's a website that talks to the internet. And when you look at this as a developer, you're like, oh, website, what? Static, Ruby, .NET, MVC, is it .NET Core? What's it running on? As a network engineer, you're like, okay, the internet, what have we got running over here? Where's the edge routing and stuff? No, we're interested in the piece in the middle. HTTP, you think, well, it's HTTP. How complicated can that be? Very complicated. How many transactions per second? Does it support options, head, put, post? What's the expiry date on the certificate? How much traffic can we put across that connection? What if we put a caching proxy in the middle? Do we have the right kind of headers? There are all of these questions that you need to understand that have nothing to do with what the website is built in or how many people are on the internet. You're interested in that boundary, the traffic that flows across it, the capabilities, what you can do with that. There's a quote from a guy called Gene Kranz who worked at NASA. He's the guy in the Apollo 13 movie. I don't care what anything was designed to do. I care about what it can do. That's the thing you've got to understand. Because lots of systems that I've seen, hey, we've got a high-performance user login system, except it doesn't support more than 5 people logging in at the same time. That's not high performance. But sometimes you'll be like, hey, do you know you've got a Redis cluster here? And someone says, oh yeah, we just right-clicked in Amazon and there it is. And it's like, This is brilliant. You can do so much amazing stuff with systems like Redis. We can use that for caching. There are always going to be stuff that isn't as good as people think, and there's always going to be stuff that's actually much better than people think. I worked with a team once who were using SMTP and POP3 as a message queue because they controlled the servers on both ends, and they're like, it's a protocol everyone understands. Every single language in the world has libraries to talk to it. We know what's on there, and when we need to troubleshoot it, we can just use a mail client to see what's in the queue. This is about 15 years ago. And you think, your first thought is, that's crazy, and then you're like, well, no, that's this. It's not what it was designed to do. It's designed to send email. But what it can do is give you long-term persistent storage of messages with attachments, and the attachments are full of XML, and it gives you this really, really flexible routing system. Now, I wouldn't actually do that, but it's a really interesting thing to think about. And so people come along and go, well, that's all right. We're working on a greenfield project. We don't have any existing code to worry about. So let's have a look at the greenfield. There's no such thing as an empty greenfield. There are going to be little bits and pieces scattered around, bits of databases, bits of spreadsheets. And some of these you're going to be able to use, and some of them you're not going to be able to use because you're not allowed, or the other department owns it, or you can't get connection credentials to it. Every greenfield project I've ever done, somebody had already tried it once and it hadn't worked, and the code was still kicking around in Subversion or GitHub or something somewhere. There is going to be some politics. There is going to be one person somewhere who you go and say, hey, we're going to use a Microsoft SQL database for the new project, and they go, oh, we can't do that. And you're like, why? And they're like, oh, SQL's illegal. It doesn't work. It causes cancer. And you're like, and then you find out this is the person who got fired for spending too much on SQL Server licenses in their last job. You're like, all right, now we know about that. We're going to ask somebody else for this bit. And there is going to be what I call the rabbit hole, which is the, oh yeah, it's easy. We just right-click, we generate the interface, and then we plug into it. And 4 days later, you're still there going, I right-clicked, and nothing happened, and I don't know what to do now because that was part of the plan. Even a greenfield project, you have all these things that you're going to need to anticipate. Part 2, work out what you got. What do you need? Now, this is not about what is the software supposed to do, because that's someone else's problem. We got user experience people, we got front-end, we got back-end developers, we got business analysts, but they are going to come to you with the same things that businesses always say. We need it to be fast. We need it to be secure. You need to be able to turn those into an actual business conversation. How fast is fast? And a business analyst says, well, quite fast. And you're like, very fast? Because what happens when they say very fast is you go to your team and you say, we need to make it go very fast. And the team go, oh, brilliant. And they all stop what they're doing and they start implementing Redis caching for everything and doing bitwise pattern analysis of incoming HTTP requests to try and get into the top 10 performance chart. And a month later, someone says, is the new project ready? And you're like, no, we're still making it fast. And the developers are having a blast because this is really fun stuff to work on. And you're not actually shipping any value because you don't need it that fast. You're not trying to win the world's fastest web server competition. You've just got a business analyst who doesn't want people to get bored waiting for a shopping cart to load. So turn it into a conversation. Help bring everyone else up to the level. You're like, right, let's talk about page load time. You want it to be fast? Let me show you what 200 milliseconds looks like. Click. Let me show you what 2 seconds looks like. Click. Let me show you what 10 seconds looks like. Yeah, that's too long. We're all bored now. And then they're like, okay, so 2 seconds is pretty good. And then you're like, okay, how many people do you want to let down? What do we want? 90% of people within 2 seconds? 95, 99? Teach them about percentiles. Then you can turn this into a conversation. They came back and say it's got to be 99%. You're like, okay, well, we can invest this much in better web servers and caching, or we can take off some of that JavaScript that you use to show adverts. What do you want? And then it turns into a business conversation. Security. Architects like, yeah, the whole system needs to be secure. Who are you afraid of? To really do security properly, you need to understand the threat models that you're dealing with. Now, there's a great talk, a guy called James Mickens, who's a security researcher at Microsoft, I believe, did this fantastic talk where he says, basically, you're worrying about 3 people. You're worrying about botnets, you're worrying about your angry ex-boyfriend, and you're worried about Mossad. Botnets are going to try that set of credentials for 1 second, and then they're going to move on because they've just got 1 million sets of credentials, and they just want to find out which ones work. Use a long password and a backoff, and that's fine. Botnets are done. The angry ex-girlfriend, ex-boyfriend, this is actually one of the big security things. You have all these users, don't share your password, we'll send a text message to your phone. The person who breaks into their account is angry with them in their house with their phone, How are you going to lock that out? You know, what mechanisms, if that's what you're worried about, how do you anticipate that kind of threat model? Mossad are already in your system. Don't worry about them. Just get on with your life. They're good at what they do, and they're winning. What can you build? You've got some requirements. It's got to be fast. You know how fast. It's got to be secure against these kinds of threat models and attackers. You understand the capabilities. Now you need to understand what is it that you and your team are actually capable of doing. There are 4 Ps you need to understand here: people, patterns, packages, and process. People's easy. Who have you got, and what are they good at? What do they want to use? You know, this is the opportunity to go, well, I know we got this team here doing .NET WinForms, but I've noticed they keep going to JavaScript meetups. They're interested in Angular, React, people doing Scala. It's where you can get people in a room and go, look, what are you good at? What are you interested in? What would you like to be working on? And you can use that. You can align the technologies that people are interested in learning with things that solve certain kinds of problems. Now, people is one thing, patterns. Some languages and platforms support certain kinds of patterns better than others. I've been doing a bit of work recently with Ruby on Rails. Ruby on Rails is so tightly coupled to MVC as an architectural pattern that the people using it don't know it's a pattern. They just think that's what Rails is. If you use ASP.NET Web Forms and you try and do MVC with it, you're going to have a rough time. That's how I spent about 5 years in one of my old jobs. Web Forms is designed to work with a post-back and a view state and a persisted model. ASP.NET MVC uses a completely different model. Choose one patterns that suit the kind of problems you're trying to solve, and then look to align the technology you're choosing with the patterns which help you solve it. Packages is about ecosystems. Someone says, I want to do this project in Go. You're like, okay, well, I know that we've got some crypto, we've got some image processing, we've got some need to connect to a legacy Oracle database with this. Does the Go ecosystem, to pick an example, has anyone built libraries for it that solve these problems? One of the things that I've often found frustrating about developing in .NET is the number of companies who have a Java API and a JavaScript API and a Ruby API, and the .NET thing is kind of on GitHub somewhere, but they're not really supporting it. Several times, my teams ended up running it because it looked like we were the only people in the world using it. Now, I love .NET as a development platform, but sometimes, if you've got to plug into all these different technologies, and there's another thing out there which has pre-built, first-class vendor-supported packages, ask yourself the question, is it really going to win you anything in the long term? And process is just about maturity. You sit a team down on Monday morning, you're like, we're going to deliver this by Friday. This is our plan. How consistently can you deliver on Friday what you said you were going to do on Monday? Because if you have one of those teams where it's like you change your mind halfway through the week, and then the next thing, the week turns into a 6-week because you keep finding problems with it, that maybe is something you just have to work through, but it is going to affect your capability to build things. Now, you want to build the things that make a difference. Everything else is the stuff that you want to buy. I have this mantra about building software systems. If you can't sell it, buy it. Never use PowerShell when you could use MasterCard. You want your team building the stuff you can actually sell to somebody, solving problems nobody else has solved. And you know, the number of times I've seen a team like, what do you do? Oh, we specialize in theater tickets. What are you working on? CMS. Why are you building a CMS? Because our theater ticket website needs news articles. Don't build that. That's not, no one is paying you to build a CMS. They're paying you for theater tickets. That's what you focus on. Get the CMS from somewhere else. Get something that does the job, push back, and justify the value you're investing in the work you are doing elsewhere. And finally, what can you lose? There are going to be systems, components, capabilities in your architecture that probably don't need to be there. Put your hand up if there's a system in your company, your organization that sends emails. Yeah, any emails. Order, thank you, welcome, password reminders. Keep your hand up if there are 2 systems that send emails. 3 systems? 4 systems? Put your hand up if you've ever been asked to audit the number of email systems in a company. Because I had to do this once. I got up to 12. And they were all independent. This wasn't like somebody did something stupid on purpose. First person went, okay, new mail message. What's the SMTP server? Thank you, mail.send, bang, done. Second person looked at that, went, okay, that's how we send email here. I'm going to copy that. Third person didn't know that had happened. They were working on a separate project. Fourth person went in and went, oh, there's 3 different ways of doing this already. I'm going to do one more. We'll rationalize it, refactor it in the next one. And this pattern, and every single one of those people is like, I have a requirement to send email, and we don't have a capability to do it. And then what happens is the marketing department say, can we rebrand all the email with the new logo and the new color scheme? And you go, that's going to take about a month. And they're like, a month to change the color of an email? And you're like, yeah. We've got email all over the place. It's been duplicated. We broke the 5th rule. Changing the color of an email is now a software architecture problem because we missed a trick on it. And so that's when you want to step in and go, right, can we get rid of 11 of the email systems and rationalize on the last one that we've got there? Once you've been through all this, you will have some idea of how to make that decision. Decide what to do. Technology, people, you'll just have a hunch, a gut feeling about this is how I think we should solve the problem. That bit, I'm not going to tell you how to do today. That bit you have to learn the hard way. I don't think you can get it from a 1-hour talk. But once you've made your decision, you need to tell people. You need to support your teams and say, this is how we are going to solve this problem. And this is where architecture gets really, really gnarly. Because in your head is this, and it's beautiful. It's this crystal palace of distributed systems and messages and firewalls and transaction processing, and this thing over here is an immutable stateless controller for things. And you try and draw this to give it to your team to say, let's build this amazing thing, and what you draw is this. And the team look at it and they go, is this Java? Diagrams are everywhere in software engineering, and we as an industry are still kind of just finding our way about how diagrams can help us build software systems. Now, I mentioned at the beginning that there are 2 kinds of architects. There's building architects and there's software architects. And when you work with a building architect, they make diagrams. They draw things that look like this. And you're like, okay, I can't quite see what that is, but it looks like you know what you're doing, and they do something that looks like this. And you think, all right, that's interesting. And then you say, can you do a drawing that kind of shows us a little bit more? And they say, yeah, all right, here. And you're like, okay, this is looking quite nice. Can you do a slightly better one? And they come out with this, and you're like, oh, yeah, this looks really good. I want to build one of these. And you do. And when you build it, the thing you've built looks like the drawing. And this applies to almost every field of design and engineering, but not software architecture. Because in software architecture, we start with a diagram that looks like this. Can anyone tell me what language this is written in? This is a formal software engineering specification diagram using a standard published notation. Anybody? Jordan DeMarco. Apparently. Anyone here know how to read Jordan DeMarco? Because I had to learn it for this talk. No, we don't. We don't really get taught this stuff. There are 6 different conventions for drawing software diagrams, and most of us don't know most of them, which means they're not really very useful for communicating with a team. So when it comes to time to do diagrams, a lot of people, and this includes me, is like, I'm going to get out my old textbooks from college and see what the diagrams look like. And I would try and draw diagrams that looked like the one in the book, because that made me feel like I was doing a good job. And it didn't help because no one could read them. First thing, put a legend on it. Don't assume your audience know what the shapes mean. Okay, here is the key to your, and suddenly you're like, all right, database or file system. Okay, so I don't know what Excelsior is, but I know that it's a database or a file system. These round things, so we've got Mercutio as a function and Norman as a function here. These arrows, okay, that's data flow, and then the square here is input-output. Now, you're still not much closer to knowing what's going on. And you're looking at these names, and you're thinking, I mean, that looks like a network file share, maybe. And Mandrill, maybe that's something to do with MailChimp, because I think I read about Mandrill. But you're no closer to understanding how to build this system. So the architect's job, start putting more detail on it. Let's put some commentary on this. So there we go. Okay, Excelsior, what is it? So one, we've put it in quotes. The quotes are a shorthand. It means, we made this up. Don't Google it. It won't help. This is a code name. It's an internal service name for something. This is a SQL Server database of customer details. I actually worked on a system called Excelsior. I said, why is it called Excelsior? The developer said, because all the data came out of Excel. So I just made the name longer. I'm like, all right, you needed a name. I don't care. Naming is hard. Mercutio here was a .NET service that populates email templates. All right, now we're getting somewhere. It's a .NET service. This is a .NET app. Sends emails. This thing over here, okay, it's a Windows file share. That's where we keep the email templates for the marketing team. And yeah, okay, Mandrill was the MailChimp's SMTP relay service. That's pretty cool. But because we've chosen to use Jordan DeMarco, we can only invent 4 kinds of things: database or file system. Now, it's kind of important to me whether it's a database or a file system. I don't want to use one shape for both of those things. Functions. What kind of functions? Functions, methods, services. Is this some kind of processing queue? Data flow, input, output. Throw it away. Nobody could read Jordan DeMarco anyway, right? So let's make up our own notation, because we're going to explain what it means as we go along. So we're going to go and we're going to find some clip art, and we're going to find some Microsoft Office thing, and maybe Google some things. And now we're getting somewhere, because you're looking at this now and thinking, all right, I'm starting to have an idea how I would build this system. Because that is what the architecture diagram is supposed to do. It's supposed to get a team of developers and say to them, hey, you know, look at this. Does it make sense? Could you go away and build this based on what we've got here? So now we've got this little key here. So the little blue cogwheel, this is a Windows service. All right, they're services. Even though it says one of them is an app, these are services. We've got a network file share. We've categorized our data flows. We've got ADO.NET records. We've got SMB. This red box down the middle with the little things on it, that's a message queue. That's RabbitMQ. You're starting to get a sense for how this whole thing hangs together. Go even further. Start annotating the data flows. What is that ADO.NET? Well, it's ADO. We all know what ADO.NET is, but hey, it's Windows authentication. Mercutio has a service account. Over here, we've got the network file share. What kind of files? Okay, it's text and HTML. Needs Windows authentication. That's how we get our email templates. RabbitMQ, where's that coming from? It's hosted on Cloud AMQP. And this thing over here, okay, it's SMTP, TLS enabled, port 993. This you can take away and actually start writing code that is going to do the right thing. That's what we started with. This looks nice. It's clean and elegant. And you look at it, you're like, oh, yeah, nice architecture. This thing here, we're going to get some work done, you know? And these things will get messy, because the examples in the books always look clean and nice. And real software is not clean and nice. It is complicated. This is a real systems diagram that I made of a system that was about to get bigger. And the team we were working with, like, can you do an architecture diagram? I'm like, yeah, all right. And I literally threw everything on. This thing we had stuck up on a wall, not quite this big, but it was like 8 sheets of A3 paper, and we'd scribble on it in meetings and stuff. And yeah, I included a legend in there. These are all the different kinds of network traffic that were flowing across the different connectors in the system. There's even a note on here, some hideous VB cursor-based library. We didn't know what that was, and we couldn't read the network traffic because it didn't make any sense to anybody at all. But we knew it was there, and we could see what it was connecting, you know. We've annotated this. We've gone in and said, here, this is a sync that runs every 5 minutes. By the way, there's a big red button in the intranet you can press if you need to do it on demand. Don't be frightened of these things starting to look complicated. Because if you're trying to document a complicated system, you need to get the complexity out so that you and your team can start working out how to reduce it, how to make it manageable. I want to say one more thing on the subject of diagrams. Here are 2 software architecture diagrams. One of these is a thing we call the hexagonal architecture. Which one do you think is the hexagonal architecture? It's this one. There's lots of names that float around in architecture, and people talk about, oh, you know, N-tier this and CQRS that and view models, and it's very, very easy, particularly when you're trying to kind of distill this information for yourself, to end up with a word that doesn't mean what you think it means, and you don't realize that. This thing here is the ports and adapters architectural pattern, which became known as the hexagonal architecture because the first article they wrote about it, they used hexagons in the diagrams. There's nothing hexagonal about it. This is crap that I made up with hexagons. But you put that in front of people, and some people will be like, oh, hexagonal architecture, very nice. Oh, I see, you know. Never, ever be afraid to go, the diagram there, I'm not quite sure. Could you just talk me through what that word means in this context? Or just like, can you explain the hexagonal architecture again? I'm sorry, I didn't understand, or I missed that lecture in college or something. A lot of the value comes once you have an environment where people can put their hand up and go, I don't understand that. Can you just run through it one more time? Because when everyone in the meeting is nodding and going, yeah, the database, and then afterwards you realize that they were all thinking of 5 different databases, that's when stuff starts going to hell. So you've come up with this design, and you've managed to communicate it with lots and lots of lines and clip arts and color coding and PowerPoint animation and whiteboards, and the team are on side. They're like, right, we get it. Let's go away and build some stuff. And they go away and they build some stuff. And the third part of your role as the architect is, how do you help them get it right? How do you reinforce the decisions that you made there? Now, there's 2 kinds of kind of checking that we do on engineering systems: validation and verification. Validation, are we building the right thing? Is the system we're working on actually going to solve the problem that we have? Verification is, are we building it right? Are we doing a good job? Are we doing good work here? Validating software architecture is hard. What you do is you come back in 10 years and you see whether the company's still in business. If it is, you probably did a good job. If it isn't, hey, maybe it wasn't even your fault. It's very, very difficult to validate architecture up front. You just have to kind of get in the trenches and work with it. But verifying it is kind of checking that the code your teams are shipping is doing the stuff that you had in your head with this wonderful crystal diagram, you know? Now, in construction architecture, you take your diagram and you hold it up like this, and you look at the building and you go, they look kind of the same, don't they? Yeah, all right. Well, this bit isn't quite right, but apart from that, you can do this visual comparison. Here's our software diagram. And the team says, hey, it's done. And now you, the architect, you want to look at it and work out, did they build the right thing? So you think, all right, I'm going to hold the diagram next to the software and see if they're the same shape. You're like, well, how do I look at the software? I know. I'll go and look at the Windows Azure dashboard. That'll show me what the software looks like. And there's a lot of interesting stuff in here, but you're like, this, no, maybe not. Maybe I'll go and look in TeamCity. I'll look at the status of all of our builds. No, not helping. I'll look at the code. Brilliant. Still doesn't quite look the same, does it? You know, like we want this, and we've got this and this and this. Is it right? Is it wrong? You know. Now, when I first started doing architecture, I made a classic rookie mistake, which is, well, you write the code and I'll review it. That doesn't work. Because one, you've got lots of people creating lots of code very quickly, and it gets very, very hard to review all of it. And also, those teams are going to start making decisions that allow them to work within their own boundary, on their own team. And you get to a point where it's like, I've reviewed your C# code, and I still don't know what it does. And dude, my team's using Scala. You get left behind. You'll burn yourself out trying to keep, either you become a bottleneck, and it's like all the code is done, but none of it can go live because the architect hasn't reviewed it yet. Or you're just like, oh, yeah, that's probably fine. Click, ship it, fine. Here's some code. We've had a meeting. We've had a big, nice design meeting, and in that meeting, we've said, all right, we're going to do data access this using a repository pattern mediated through an identity map. And a bunch of people in the meeting have nodded and gone, okay, yeah, we're going to do that. The architect has spoken. We go away and do it. What can you tell from reading this code? You can tell that they thought identity map is an important word that has to be in the code somewhere because people said it in the meeting. This code doesn't tell you what it does. This code doesn't tell you anything about behavior. This code just tells you what names have been chosen for these components. And if you agree the names in a meeting, then the names reflect what was in the meeting. They don't reflect what was in the code. It's like this. You're wandering around a city at night and you see a sign. You're like, oh, it's a luxury hotel. And all you can see is the sign. So you go and check in. You wake up in the morning and you're like, yeah, maybe I shouldn't have trusted the labels that were used on things. So what can you do to try and help and support your teams to build the right thing? Now, one of the key ones is about alignment. We talked about this a little bit earlier in terms of what have you got? Who are your people? What technology they're good with? Be prepared to fight to move things around. You've got a bunch of people who want to do functional stuff in F#, and you've got a bunch of stuff doing back-end computations. All right, see if we can get those people working on that thing and make it easy for them to communicate. High bandwidth between them. Put them in the same office. Give them their own Slack team or mailing list or video chat, whatever. You've got a bunch of front-end people doing Angular. Make it easy for them to collaborate. This way, the boundary between your front end and your computation system will emerge as a result of the way the people are communicating with each other. It's called Conway's Law. You can go a step further. You can do this. You can be like, all right, These are our components. We've got Angular, we've got the Android app, and we've got the F# quoting engine. We're going to do this bit in Belarus because there's really, really good F# developers in Belarus. We're going to put all them over there. They can do that thing. We're not having to worry too much about, polluting concerns across this boundary here because these people are going to speak to each other in Belarusian or Russian. And these people are going to speak to each other in English, and the Android team are speaking to each other in Portuguese. And we're going to hire some bilingual architects to enforce the domain boundaries. Now, I wouldn't actually do that. And I've worked on some really, really good outsourced projects. But putting the people who share code concerns physically or conceptually close together, they're going to invent code that's tightly coupled. And they're not going to tightly couple with the code that's 3 time zones and a Skype call away. Those people are going to come up with another component. And you're going to be able to mediate the interfaces that connect these different systems. It's called the domain architecture isomorphism. It's when the architect goes, boss, we need to send some people to Belarus and some people to Portugal, and the boss goes, what? And you go, if we don't move them, the system won't work. And eventually they go, all right, we'll try it. Now, the other thing that you can do once you've got this kind of team structure mapped out, start designing the interfaces. You don't want to be writing the code on these teams as the architect, because that's their job. Trust them to do it well. But what you can do is you can work with them on, all right, we got a team here who are building an API server, and they are going to need to respond to some JSON messages. So I'm going to help them design the JSON. And we got a front-end team over the other side, and we're going to start building some tests. They got this API client they're spoofing out. I've got that the wrong way around. This is the front-end team. We're going to build an API server that responds with fake JSON. And then this team here are going to write tests that get real data out. This allows both teams to start working pretty much immediately on their own implementations, and when they're done, what you can do is you can plug these 2 pieces into each other, and if you got this bit right and this bit right, they'll just start talking to each other. And as the architect, that is where you want to have a look at what's going on, because you'll have a feel for how much traffic should be flowing across here. What should these JSON messages look like? How many times should the authentication token be getting refreshed? Now, one of the questions that comes up a lot is, should architects code? Now, yes, they absolutely should, because if you stop coding, then you're going to get bored and you're going to get left behind. But you shouldn't be writing production code. The reason for that is things are going to change. You're going to have interesting ideas about how to evolve the architecture of your system. And if you're writing the code, there will be a day when you're like, oh, I can't be bothered to update the diagram. I'll just do it. And then the team comes back and they're like, what did you do here? And you're like, it's just a little fix, don't worry. And the next time it's a bigger fix, and the next time it's a bigger fix, and 2 weeks later, the rest of the team are like, fine, you do it. You know better. We're going to go and work on something else. You want to avoid that. You need to keep yourself honest, because, I like writing code. I like shipping things. The best thing I found to do is that the architects code the dashboards and the monitoring systems. Write the integration testing stuff. Write the tools you're going to put up on the big screen on the wall that monitor how the system is working. One, that gives you enough scope to actually pair with the developers on those teams. Come on, we want to put a graph on this thing. We want to, even if it's just a traffic light system, red and green. Red means it's broken, green means it's working. Pairing with the people on those teams means you get an insight into how the code is working, but you don't become a blocker on delivering that code. You get to pull in code from multiple systems and integrate it in one place so you can see it all on one big screen. And you get to build stuff. You get to write things. You get to have your code up there running on the wall. You don't lose touch with what it's like to actually go, damn it, Visual Studio has crashed again. We really need to do something about this. There's one other thing that I think is a really important aspect of the the architectural role and mediating that relationship between developers and business. Your devs are all like, this sucks. We migrated everything to MailChimp, and we don't like it because their API, I'm not picking on MailChimp, it's just an example. We moved to MailChimp, and we really aren't enjoying it very much. And you're the one who has to remind them. Do you remember last year when every Friday we had to spend 2 hours pulling CSVs out of the database so they could send email? And everyone goes, oh yeah, I do remember that. And you're like, and you remember when it didn't work and we didn't get to the pub until 9 o'clock because we were stuck here making mailing lists? And they're like, yeah, we do remember that. And you say, do you remember that we don't do that anymore? And they go, yeah. And you say, why do you think that is? And they go, oh yeah, because we integrated MailChimp. A lot of the time, when problems get solved, particularly when they get solved by delegating it to a software as a service or a different component, the developers don't see any of the benefit Because all that happens is something that used to be business as usual gets taken away. And we forget about that really quickly. And they get left with the integrating with the PayPal endpoint and the WorldPay endpoint and the this endpoint and the dynamic CRM. And lots of these integrations they have a lot more XML in it than I ever wanted in my life, put it that way. But part of your role is to remind them, look, what we did is actually the right call. That team is now sending marketing emails without blocking on us. We're not stuck here on Friday nights. Suck it up, write the XML. Once this is done, we're going to move on. Now, I just want to kind of wrap all this up. You know, architecture is one of, I don't know, a dozen things we've talked about just here today at .NET Summit. We talked, you know, Conrad opened us up with this talk about reference types and read-onlys and immutables. We've had stuff about HTTP and security and a bunch of talks in Russian that I don't even know what they were about. And all of these things are because we want to write good code. And this is the XKCD flowchart for how you write good code. You can start the project and you can go do it right or do it fast. And if you do it fast, does it work yet? No, round and round, oh, yeah, but it's a mess of kludges and spaghetti code. Or you do it right and you code it well and the requirements change and you throw it all out and start over. What I think makes good code is good developers looking at some code and going, I can make this better. I have an idea. And everything that we talk about doing, unit tests, integration tests, all of these different type systems, architecture, networking systems, is about giving those developers the freedom to try it and see if it helps and manage the risk that they're going to break something. Good architecture, over time, will take a bunch of teams and it'll put each of those teams in a place where they can go, we think we can improve our component, and we know that if we do this, it's not going to break anything. It is another technique that just allows people who know what they're doing to look at some code and go, I have an idea. Hey, take a look at this. Can we try this? You try it. If the tests are green and the interfaces are up and the dashboard looks good, you've made it better. Ship it. Thank you.
Thank you very much, Dylan. Any questions? Raise your hands.
I have a question. Where do we get beer?
In about 30 minutes, we're going to have the after party in a pub called Dandyland, I guess, right? Yeah.
Yeah. You notice that Dandyland has got Dylan in the middle of it.
Oh, right.
Yeah.
You're going to be in charge of the beers, right?
All right. But you're paying.
Yeah, I only one from yesterday, so.
Yeah.
Sorry that I'm just pulling the moment with the beer a bit.
That's all right.
Thank you very much for such a great talk. You definitely could make at least 3 separate talks. A dull question, full stack, right?
Mm-hmm.
Full stack developer. When you have boundaries, front end, back end, separate teams, it's clear where do you put yourself in it.
Yeah.
And when developers implement vertical slices in full stack scenario, where do you put yourself as an architect there? You just okay. Oh,
yeah.
Thanks.
So if I understand the question right, you're talking about you have teams where it's like this is all the front end across all of our different products, say, and then this is all the back end, this is all the data, but you also have the vertical slice thing, where it's like this is a full stack independently deployed application that does, say, financial transactions and stuff. So architecture works at a lot of different levels. You know, it may be in that kind of organization that each one of those full stack development teams has an architect, and then people just pick different bits of work. You know, just because you have people on your team who are capable of working at every level doesn't mean you shouldn't have boundaries between those levels in the way the code is being built. Now, I actually, you know, full stack, the first time I heard the expression full stack was probably like 15 years ago, when full stack meant you knew HTML and SQL. And that was like, you could do front-end web pages and you could do back-end databases. And full stack, the term, has evolved a lot, and now it got a lot of credence out of the whole Node.js thing about you can now run JavaScript on the back end and the front end and do persistence with it. I'm still not entirely sure that people who talk about full stack developers all mean the same thing when they say, oh, we full stack team, we do all this kind of stuff. But there's always scope for architecture to happen as part of those roles. There's always scope to have a design up front, even if you then keep evolving it and you don't necessarily stick rigidly to it. And yeah, it depends. If you decide you want to do vertical slices, what you probably end up with is architecture happening within each of those vertical slices just to make sure the pieces are lined up. But then you have what Spotify call, is it Spotify, the squads and guilds model? Because yeah, you also then, you got 5 different teams and they've all got front-end people. You're like, well, we should let them get together once a week and talk about how to do front-end well. And at that point, you're going to have some architectural ideas coming out about how to manage things like front-end component libraries and how to unit test JavaScript and these sorts of things happening. So I realize that's a bit of a roundabout answer. I don't have a quick and easy answer for that. Give us 15, 20 years, maybe we'll figure it out.
Thank you very much.
Any other questions? Yeah.
Thanks for your talk. Could you please put some clarification regarding words that was from guy from NASA? And you're talking about it could be okay that using something in situations that it wasn't intended to. So I have a question. But if we try to use something that it was not intended to, in one day we can come up with a problem that we need some updates for. Everything is evolved, and if we use something in a wrong way, in some day we can want to some update from this instrument, but it doesn't fit to our needs, and we will have to switch to normal ways of solving problems. So like for example, from your example about using mailing protocol as a queue, well, in some day we would like to add another some cool feature that required, but this protocol doesn't allow us. So
it's about, like I said, there's 2 sides to this. One is you want to understand the things that don't work as well as they're supposed to. Because that's one of the constraints. Someone says, oh, don't worry about authentication. We have a login system. And you want to dig into it and be like, well, I don't care that it was designed to be a high-performance distributed authentication system. I care about what it can actually do, which appears to be send 1 email every minute and then crash. That's not good. The other one, you're incurring a certain amount of technical debt when you do this. You're like, we have a component here that we can use right now which solves the problem we have today. And a lot of time it's like, let's solve that problem today and make sure we know that here are the boundaries, the limits of the decision that we've just made. It's it takes a lot of discipline to do it in reality, but when you have like regular, sprint planning meetings or retrospectives, keep track of all the decisions you made in that thing that might come back and bite you. And then also go and make a business case. You're prioritizing some work for the next month or next quarter and be like, we have some technical debt that we want to recover. We're using POP3 as a message queue at the moment, and that's not very good. We want to move it to RabbitMQ. Get the time from the business, but make a note of the fact you've done it, because then sooner or later something else will come back, and the business, the stakeholders, will be, hey, can you implement a feature that does this? At which point you want to be able to say, okay, well, do you remember that work we did to get the message queue system updated? Actually, because we did that, this is now going to be cheap. And so that way you close the value loop for them. So you're like, we want to spend some time now, but it's going to save time later. And if you say it now and then you don't talk about it later, they're going to forget about it. But all this kind of stuff is about understanding capabilities of components, and sometimes things are a lot more capable than they were intended to be. Sometimes you have stuff which was supposed to be very, very good, but actually it has problems and headaches in it. Operating system security issues, network firewall, bandwidth limits, all this kind of stuff. And it's just about making sure that you understand that and you take it into account in the decisions that you're making. You want to use email as a message queue? Go for it. Just wake yourself up every day and go, we're still using email as a message queue. We should probably do something about that. So does that help?
Partially.
Okay. Yeah.
Thank you.
Kamala. We'll discuss emails as a queue system with beers. Any other questions?
I actually have one.
Okay.
It's a bit of a sidetrack, but
okay.
What are your thoughts on the architect's role in actually shaping the product in a way that it is easy, or let's say in a way that it is maintainable? Like, I remember you said that, well, what to do is the business people, they decide.
Yeah.
But can you elaborate on that? Or is it just like they tell me what to do and I just do it? Or do you see there's an architect as a person who's actually shaping the business as well?
Okay, I think that the best products emerge from teams where the architect is involved in that conversation. But I also think that a lot of people out there are not creating the best products in the world. I don't know, use smartphones as an example or something. You know, there's the kind of the Samsung Galaxy, and there's the iPhone, and the integration of software and hardware and features and capabilities. Then there's a whole load of other phones which are not quite as good as those phones. But still, there's teams working on those things that are doing good work. I think it's one of those things where it's very, very difficult when you're kind of doing this kind of work. Because a lot of architects get promoted internally, particularly in teams that are growing. They'll say to somebody, well, you know, you've been lead developer for 2 years now. How do you feel about being the architect? And sometimes, at that point, it's like, cool, right, get me into the boardroom. I'm going to shape our product strategy for the next 2 years. There isn't like a day when that's the day you decide you're going to go and do that. The involvement happens gradually, and sometimes what happens is the architect gets more and more involved in those things, and they become frustrated that they're not getting a seat at that table, and then they go and look for a role somewhere else, which is more kind of, you know, digital product architecture than back-end systems engineering stuff. I do think that good, healthy teams have this synergy between architectural capability, software, usability, finance, ethics, but it's very, very hard getting that right, because you need really strong people covering all of those who also all work very well together to do it. And you know, I don't want anyone here to go back and go, oh, yeah, I liked my job, but then I went to .NET Summit and they said that the architect should be designing the product, and now I hate myself. There's a lot of people out there, you know, doing really good, satisfying work who don't get involved in that process just because of the way the organization they're working for is engineered. And that's okay. You know, stick with it, learn from it, do good work there. Maybe when the time is right, you'll be like, okay, now it's time to go and get more involved with that. So yeah, I think it's, when it happens, it's like the self-organizing teams thing. If that's the organization that emerges, then you're probably going to come up with some very, very good stuff. But if it's not emerging naturally, find a way of working without it in the meantime. So,
sounds cool. Thank you very much. So, any other questions? We have just time for one last question.
We have one in the back
last
there.
row.
Yep, one there.
Is there a mic? No? I'll bring it there. I'm running.
So one of the creators of the Agile Manifesto, Bob Martin, said that the architect that doesn't write production code can't. So they produce some solution for developers, but they don't put into the place of these developers. So, however, you told that the architect should not write production code. How to solve this contradiction? So how to understand the needs of your developers for whom you create this solution?
Let's shorthand us by saying that Bob Martin and I don't agree on everything. But he's been doing this longer than I have, and he has a certain set of ideas based on what he's seen. And I have a certain set of ideas based on what I've seen. The reason why I like the idea of building dashboarding and monitoring systems as an architect is because they're not customer facing, you don't sell them, but they're prominent. They're on a screen where all the people in your business, the engineers and the non-technical people, can see them. And so it kind of reminds you that at the end of this process is a real person looking at a screen and trying to get something done. So to me, it kind of keeps you in the right mindset, but it doesn't make you a blocker on the critical path for actually shipping stuff to customers. I think I know the Bob Martin article you're talking about. And you know, he has, read him and then listen to me and then go away and think about it and then come up with something that takes the best of his stuff and my stuff and puts that together into something that you think works. and then come back next year and stand up and tell us about it, and then somebody will go, yes, but I read Martin Fowler's book, and he said, you know, we're all trying to get better at what we do. And software engineering is a really young discipline. You know, I was talking with Steve in the cab yesterday about we still don't really have anything good for making diagrams. You know, I mean, the stuff in here I did with Visio and clip art. And, you know, we should have tools now that are like, please, here's a distributed system. Give me like a Google Maps style. This is what you were saying in the car, Steve, about why can't I explore software like Google Maps? Like, hey, give me directions from the back-end stack to this JavaScript component. I want to see the stack call that goes through it. We're not even close to that yet. And so, you know, all of these ideas and observations is people sharing stuff that worked for them and putting that out there and saying, hey, this worked for me, you try it. And then you take that and share it back with us and all that kind of stuff. And yeah, I know Bob Martin thinks you should write production code. I think you probably shouldn't. That's because when I was an architect and I tried to write production code, it caused massive problems. Right.
Thank you.
You're welcome.
Thank you very much. So let's thank Dylan so much for his talk.